Hi, I'm Tina from Prep 101. In this video, I'm going to review domain and also look at harder domain questions that will appear on your first exam. Okay, let's get started. So domain tends to be something that students have trouble with, tends to be a tricky topic. So the domain of the functions is a set of the x values. Okay, so that's what you need to know about domain. They don't tend to ask you about the y values or the range. It tends to be domain that they focus on. So there are different cases. So the first case is when you have a fraction. So what you can write down is when you have fractions, set your denominator equal to 0. And that's how you'll figure out what values you can and cannot have. So if we look at the denominator, the bottom, we know that the bottom cannot be 0. We cannot divide by 0 in the real numbers. So we've got f of x is x over x squared minus 4. So we set the bottom, x squared minus 4 cannot be 0. Factor that. Difference of squares, so x plus 2 and x minus 2 in any order, cannot be 0. So if x minus 2 cannot be 0, then x cannot be 2. And if x plus 2 cannot be 0, then x cannot be negative 2. And instead of just writing it like that, they make it a little confusing. So they'll write the domain as from negative infinity up to negative 2, union, meaning or, negative 2 to 2, or 2 to infinity. Now, all of these round brackets mean that the number is not included. So round bracket means negative 2 is not included. If it was a square bracket, then that would mean that the negative 2 and the 2 and the 2 here were included. Infinity and negative infinity, since they're not exactly numbers, we never put a square bracket around those, okay? So infinity is not actually a number, so we put round around both negative and positive infinity. And that would be our answer. Okay, the second one here, when you have a square root, set the term under the root greater or equal to 0. Okay, so whatever is under the root, not including the root, has to be greater or equal to 0. That's where we define square roots. We can take the square root of 0, but we can't take the square root of a negative. So we've got f of x or y equals root x minus 5. So we say x minus 5 greater or equal to 0, x greater or equal to 5. And so domain here, 5 is included, so it's a square bracket. So here, 5 is included in our domain. So square bracket from 5 to infinity, round bracket. And if we have both fractions and a root, you have to consider both at the same time. So if we look at, let's say, the denominator, then we know that x squared minus 4 can't be 0. So we got that x cannot be plus or minus 2 from that. But we also know that x squared minus 4 has to be greater than or equal to 0. So that means x squared is greater than or equal to 4 here. So let's think about a number line and let's test what numbers will work here. So I'm just going to draw out a number line up to between negative 3 and 3, and of course it goes on this way and on this way. So let's look at what numbers we have. We know that we can't have plus or minus 2, so those are open circles. We're not coloring in because we can't have plus or minus 2 from this one. And now let's look at what we've got from the other one. So whatever number squared has to be greater than or equal to 4. So let's say 3. 3 squared is 9. That's greater than or equal to 4. 4 squared is 16. That would work. Does 1 work? Well, 1 squared is 1. 1 is not greater than or equal to 4, so 1 doesn't work. 0. 0 greater than 4. No. Negative 1 squared is 1. 1 greater than or equal to 4 is not true. But negative 3 is true because negative 3 squared is positive 9, and 9 is greater than or equal to 4. And so we get our domain as going from 2 up, but not including 2, and from negative 2 down, but not including the negative 2. So x is greater than 2 or less than negative 2. So how would we write that? Can you try and write it out? Hit pause and see if you can write what the domain would look like here. So we would have from negative infinity up to negative 2, or from 2 to infinity. And round brackets because we can't have 2 or negative 2 included because that would make the denominator equal to 0. Okay, so here's an interesting one. We're going to look at a ln next. So here we have find the domain of y equals ln of x minus 2. Well, your line graph, if you just look at ln x, kind of looks like this. So that's the basic shape of a log graph. And so here we know that we can't take the ln of anything in the negative and we can't take the ln of 0. we know that x has to be greater than 0 for ln x. So when we do the ln of something else, we just say that whatever we're taking the ln of, in this case x minus 2, has to be greater than 0. It can't equal 0 because we can't take the ln of 0. So this would mean that x is greater than 2. So our domain would be from 2 to infinity, with round brackets because x cannot be equal to 2 in this case. So for the next example, you need to know the domain of arcsine, arccos, and arctan. So arcsine has a domain of -1 to 1, and so does arccos. Think about your sine and cos graphs. They oscillate between -1 and 1. And so the domain of arcsine would be -1 to 1. Same with arccos. Arctan has a domain of -infinity to infinity. So it's good to memorize those three just in case you get a harder question on the exam. So one of the ones that's come up commonly is find the domain of f of x equals e to the arc cos x here, e to the arc cos x. So one thing, people look at the domain of e to the x is -infinity to infinity. But you can't use that for e to the arc cos x because whatever goes in here for x is going into arc cos, and then it's being e. So we know the domain of arc cos x is from -1 to 1. So those are the only values that you can put in there, and then you're going to e those answers. So the domain of f of x, e to the arc cos x, is just -1 to 1. And that's our answer. Okay, and the last one here, number 6, find the domain of f of x equals cos inverse, or arc cos, of e to the 3x, e to the 3x. So first thing we look at is the domain of arc cos, or cos inverse x, we just talked about, -1 to 1. And so we can say whatever we're taking the arc cos of is between -1 and 1. So our e to the 3x is between -1 and 1. Now we know that e to anything is always going to be greater than 0. E to anything is not going to be 0, and e to any negative number is just 1 over that number, so we can't get a negative number from that. So since we know that e to the 3x is always positive, we can say, well, this really simplifies to 0 greater than e to the 3x less or equal 1. And now to get rid of the e here so that we can actually solve it for x, we're going to ln everything. So ln 0 less than ln e to the 3x less or equal ln of 1. Ln of 0, if you look at your ln graph, and it goes like this, as you approach 0, you're going down to -infinity. Here, we use our log rules, and once we have a ln, we can put the exponent down in front. So this is 3x times ln e. And ln of 1 is 0. Ln of e is actually equal to 1, so we can simplify this to -infinity less than 3x less or equal 0. And to get x, we're going to divide all the terms by 3. -infinity divided by 3 is still -infinity, still a large negative number. 3x divided by 3 would be x, and 0 divided by anything would be 0. And so this will just be less than. And so our domain here would be, we can go from -infinity all the way up to 0, and it can include 0, so it would be a square bracket at 0. I hope you found this video helpful. If so, see more videos in this playlist. Don't forget to join the Facebook Study Hub. Use the link in the video description box. Also, I hope to see you at my prep sessions, where I'll show you lots of tricks on how to ace your exam. I'll go through every problem that you need to solve, and you'll solve them with confidence by the end of my prep sessions. Many of our prep sessions are free, so go to prep101.com now for more details and to sign up. I hope to see you soon. Take care. Bye.